Mathematics is a broad and foundational discipline that encompasses the study of numbers, quantities, shapes, patterns, structures, and change. At its core, mathematics is the language of logic and precision, providing tools for understanding and describing both abstract concepts and real-world phenomena. It is often considered the purest form of intellectual inquiry, built upon axioms, definitions, and rigorous reasoning. Unlike empirical sciences that rely on observation and experimentation, mathematics proceeds through deductive logic. Conclusions follow necessarily from a given set of premises. This makes mathematical truths timeless and universal. The statement that 2 yaoan, 2 equals 4, is as valid today as it was millennia ago, and it will remain so indefinitely, regardless of context. Mathematics is divided into several major branches, including arithmetic, algebra, geometry, calculus, and statistics, each with its own set of concepts, techniques, and applications. Arithmetic involves basic operations with numbers addition, subtraction, multiplication, and division. Algebra introduces variables and symbols to represent numbers and relationships, enabling the formulation and solving of equations. Geometry explores the properties of space, shapes, and configurations, while calculus investigates change and motion through the concepts of limits, derivatives, and integrals. Statistics and probability, on the other hand, provide methods for analyzing data, making predictions, and understanding uncertainty. Over time, mathematics has evolved dramatically, expanding into areas like topology, number theory, logic, set theory, combinatorics, and abstract algebra. These higher branches explore structures and patterns that are often far removed from everyday experience but are crucial in advanced science and engineering. The beauty of mathematics lies in its abstraction and generality. It reveals underlying similarities between seemingly unrelated problems and provides elegant, sometimes surprising, solutions. For example, the same mathematical principle can describe the growth of populations, the orbit of planets, and the spread of disease. Mathematics is also deeply intertwined with the natural sciences. Physics, chemistry, biology, and even social sciences rely on mathematical models to describe complex systems and predict outcomes. In physics, particularly, mathematics serves not just as a descriptive tool, but as a guide to discovery. Many theoretical breakthroughs, such as Einstein's theory of relativity or quantum mechanics, were made possible by mathematical insight. Computer science, an increasingly dominant field in our digital world, is fundamentally mathematical at its core. Algorithms, data structures, computational complexity, cryptography all rest on mathematical principles. In economics, mathematics provides models to analyze markets, optimize resources, and forecast economic trends. Engineering, from the design of bridges to the construction of electronic circuits, depends heavily on precise mathematical calculations. Even in art, architecture, and music, mathematical patterns and proportions have played a significant role, from the symmetry in classical art to the use of the golden ratio in design and composition. Historically, mathematics has been practiced in every ancient civilization, from Babylon and Egypt to Greece, India, China, and the Islamic world. Ancient mathematicians like Euclid, Archimedes, Aryabhata, Al-Khwarizmi, and many others laid the foundations of arithmetic, geometry, and algebra, which were further developed and formalized in the modern era. The invention of calculus by Isaac Newton and Gottfried Wilhelm Leibniz marked a turning point, giving birth to powerful tools to describe change, motion, and the infinite. In the 19th and 20th centuries, mathematics became increasingly formal and abstract, with mathematicians like Gauss, Euler, Cantor, Hilbert, and Gödel reshaping the discipline with revolutionary ideas in number theory, set theory, and mathematical logic. One of the most profound developments was the realization that mathematics could study its own foundations. This led to the emergence of formalism, intuitionism, and logicism, three major philosophical perspectives on the nature of mathematical truth. Formalists view mathematics as a game played with symbols, according to specific rules, independent of any inherent meaning. Intuitionists believe that mathematics is a mental construct, grounded in the intuitions of the human mind. Logicists, like Bertrand Russell and Alfred North Whitehead, attempted to reduce all of mathematics to a system of logic. However, Kurt Gödel's incompleteness theorems in the 1930s shocked the mathematical world by proving that no consistent system of axioms can be both complete and capable of proving all truths about the natural numbers. This fundamentally altered the philosophical landscape and revealed inherent limitations in formal mathematical systems. Despite this, mathematics remains a remarkably robust and unifying discipline. In education, it develops critical thinking, problem-solving, and analytical skills. Learning math is not just about mastering formula. It is about learning how to reason clearly, approach problems methodically, and persist through challenges. In everyday life, we use mathematics more than we often realize when we budget our expenses, measure ingredients, calculate distances, or compare interest rates. In a rapidly advancing technological society, mathematical literacy is more important than ever. Furthermore, mathematics also possesses an aesthetic dimension that many outside the field may not immediately recognize. Mathematicians often speak of the beauty of a proof, the elegance of a theorem, or the simplicity of a model that captures complex behavior. Famous results like Euler's identity, which links 5 fundamental mathematical constants in a single stunning equation, V, ni, 1, 1 equals 0 me, are celebrated not only for their utility, but for their profound and unexpected unity. The field continues to grow, with new conjectures, unsolved problems, and entire branches emerging. Some mathematical problems have remained unsolved for centuries, such as the Riemann hypothesis or the Navier-Stokes existence and smoothness problem, both included among the Millennium Prize problems, each carrying a 1 million reward. Mathematics is also increasingly collaborative and global, with researchers across continents working together to solve complex problems, aided by powerful computers and advanced software. In this digital age, mathematics plays a pivotal role in encryption, artificial intelligence, machine learning, and big data analysis, shaping the future of communication, medicine, finance, and more. Ultimately, mathematics is far more than a school subject or a collection of formulas. It is a way of thinking, a universal framework for understanding the world, and a human endeavor that has persisted and evolved for thousands of years. It represents our deepest curiosity about the nature of reality, our desire for order and meaning, and our pursuit of truth through reason. Whether one sees it as a creative art, a logical science, or a philosophical quest, mathematics continues to inspire, challenge, and empower humanity in profound and transformative ways.